Hello everyone, my name is Jayam Arutia and my roll number is 20ME30023.
Hello everyone, my name is Akash Tripathi. My roll number is 20ME 30005.
And my name is Anuj Kumar, and my roll number is 20ME 10016. And this is the assignment 5 of mechanism sessional. And for this, we choose the problem statement of a railway ladder system is being contemplated for ease of accessibility to train coaches from platforms of different levels, as shown in the next slide. Synthesize and make a simulator for the ladder with new ideas, and this is the figure given in the problem statement. So let's start with the concept of dead center synthesis of 4R mechanism. So this is the diagram of 4R linkage. uh, these are the four links L1, L2, L3 and L4, and these are the angles made by them with the ground. So in this, the dead center configuration is achieved when the input link and the coupler become collinear. That is, the revolute joints of these two links are in a straight line. Such a configuration also corresponds to a limit or extreme position when the linkage is driven from the output side. That is, the current driven or output link made the input or driver link. Such configurations are important in designing of quick return mechanisms such as Viper. Uh, these are the this is the 4R general linkage configuration. In this, you can see the crank and the coupler can be arranged in a random position, and when crank and the coupler arranged in a straight line or a collinear, this is called 4R dead center configuration. So in this, the output link oscillates between theta 41 and theta 42, but the time taken to move from the theta 41 to theta 42 and back to theta 41 from theta 42 is different for a constant speed of the input link. The ratio of these two time intervals is called the quick return ratio. The input link completes a full rotation. Thus, the synthesized linkage will be a crank rocker. Dead center configuration is also important in optimizing the transmission ratio of a 4-bar mechanism, since the transmission ratio is minimum at this configuration. So, Jay will explain the concept of dead center synthesis with 3R1P mechanism.
So the concept of dead center synthesis with 3R1P mechanism is as follows. The dead center configuration is achieved when the input link and the coupler become collinear. That is, the revolute joints of these two links are in a straight line. So this is the schematic diagram of 4 bar 3R1P linkage. This is the link 2, this is link 3, the link 4 is prismatic pair and the link 1 is ground, and the angle made by all links with respect to ground are shown in this figure. Now this is the 3R linkage general configuration, and when this crank O2A and coupler AO4 are in straight line, then this configuration is called dead center configuration of 3R1P linkage. So the output link oscillates between S41 and S42, but the time taken to move from S41 to S42 and back to S41 from S42 is different for a constant speed of an input link. The ratio of these two time interval is a quick return ratio. The input link completes a full rotation, thus the synthesized link will be a slider crank. So now we move on to SolidWorks for the simulation work. Firstly, we create a sketch of this dead center 4 bar dead center mechanism, and after a lot of optimization, we set the dimension of their links. So this one is of 505 units, and this is of 100 units. This link is of 90 units, and finally this ground link is of 328.09 unit. So basically, this whole ladder mechanism is based on this 4 bar locking mechanism. It has two dead center configuration which lock the ladder in horizontal and vertical position so that there will be no load on the motor. After this, we make a separate CAD model of this 4 bar double locking mechanism. So as you as you see here, one dead center is here and the another dead center is in this downward position. So now we move on to our ladder mechanism sketch. It is here. So here is our 4 bar linkage, which is the base of this mechanism. Here it is shown in this dashed line. Now, after this 4 bar mechanism, we synthesize our remaining mechanism in such a way that in one data center configuration, the ladder is in horizontal position as you see here, and in another data center configuration, the ladder is in vertical locking position as you shown here. This is the simulation of this, and basically in this mechanism, the most important linkage is this one that takes the load of ladder at the time of dead center, so it takes the load of the motor. Here are the two steps of the ladder whose lengths are of equal length and make the parallelogram configuration. So the steps always remain in this parallelogram configuration and move equivalently. And the other links dimension are as shown in the figure. And this one is the main link of our mechanism which hold our setup. And this end of this mechanism is grounded, and here it's make the angle of 166 degree. And the length of our step is 300 units. And then we switch this sketch in the 3D model. And here it is our 3D model. And in the red color, it is our 4 bar linkage, and here it is our parallelogram configuration of the steps. So now I play the simulation in the side view. And it is like this. And now I change the view of this model in the isometric view. So this is our model in this isometric view. And now I play the simulation in this view. So this is what we done in this assignment. Thank you.